right, 2.1 is factoring difference of squares. Okay, and to start off with, you know, if you put it up top, we're going to take a look at when you have the opposite things, like x plus 2, x minus 2. When you multiply it out, what happens is x times x. You know, if you're doing FOIL first, is x squared. This would be negative 2x. This is positive 2x. And then this would be negative 4. And what happens when you have these where they're opposite things, these will be opposite, they cancel out. And what you end up with is x squared minus 4. Now we call both of these are perfect squares because this is x, which you're squaring, and this is 2, which you're squaring. Okay? Now, by the way, anytime you have any of these integers, these are all perfect squares. 1, 4, 9, so on. You know, this is 8 squared, 9 squared, and so on. So these are things you might see when you're dealing with perfect squares. Okay? All right, if you take something a little more complicated, it doesn't just have to be x. Let's take 4x plus 5, and let's multiply this by doing a box, which some of you guys may have done before. So this would be 16x squared. This would be 20x. This is negative 20x, and this would be negative 25. So if you look and you add these together now, you get plus 20x, minus 20x, minus 25. Once again, these x's cancel out, and you end up with perfect squares. And you might, well, is this a perfect square? Yeah, because 16 would be 4. Oops, actually forgot that one here. 4x squared minus 5 squared. Okay, so what we're going to look at is when you do perfect squares like this, and we sort of go backwards, we have this general formula that if you have a squared minus b squared, like we do in this case, okay, and here's another one, what it factors to be is a plus b, a minus b. But the main thing when doing these problems is figure out what is it that you're squaring, and then you write it out like this. Now sometimes if you look at these 4 examples, they tell you exactly what you're squaring. These last ones, you got to figure out what you're squaring before you can do that. So for the first one, they tell you, all right, you got 5 squared minus x squared. So it'd be 5 plus x, 5 minus x. Now it could be constant and a variable. It doesn't have to just be one or the other. So in this case, these are the two things I'm squaring. So it'd be 2x plus 8 and 2x minus 8. All right, now for number 3 and 4, that's where you figure out what is it I'm squaring. You know, what is it here and what is it here that I'm squaring? So I got to figure that out before I can write it as this plus this and so on. So if you look here, 9 would be 3 squared, and then x squared is just would be x. So if I square this, I get 9x squared, and 64. That would be a perfect square. Well, that would be 8. Okay, so when I do this, I'll do 3x plus 8 and 3x minus 8. All right, last one here. I suggest you pause and then come back to this and see how you did. All right. So 16 is 4 times 4, and x squared would be x times x. So it would be 4x squared minus 6 times 6 is 36. So those are 2 perfect squares. So now I can factor this to be 4x plus 6 and 4x minus 6. All right, so that is factoring a difference of squares. You can go ahead and do your practice. After you're done with your practice, you probably want to do a nice diagnostics, check to see where you're at, and if you do well in the diagnostics, you should be ready for the third focus area assessment.